You ever just stop and get that really weird feeling that maybe none of this is real? That our whole lives, our whole universe, could just be some incredibly advanced program running on a computer somewhere? It's a wild idea, right? Something straight out of science fiction. But is it just science fiction? Well, let's get into it. So, what we're diving into today is called the simulation hypothesis. And it's this really radical idea that our reality isn't the base reality, that we're actually living inside an artificial one, sort of like the most immersive, high definition video game you could ever possibly imagine. So, it all really boils down to this one massive question. Could everything we know, the galaxies, the stars, even our own thoughts and feelings, just be lines of code in some super advanced computer program? It sounds crazy, but you'd be surprised who's taking this question seriously. And look, the reason this isn't just some fringe idea is because some pretty major players have brought it into the mainstream. I mean, when someone like Elon Musk says he thinks it's most likely we're living in a simulation, you kind of have to pay attention. Even Neil deGrasse Tyson has said the odds are better than 50-50. So what are they all on about? Okay, so let's get a really clear definition here. The simulation hypothesis says that everything you see, everything you feel, your entire experience of life was all coded by some intelligent being. And we, our minds, our consciousness, are just part of that computer code. The really controversial part isn't that the universe follows rules. We know it follows the laws of physics. It's that there's another reality, a programmer, who's actually pulling all the strings. So why on earth would anybody actually believe this? Well, the most famous argument for it isn't based on any physical evidence. It's actually based on a really fascinating piece of philosophical logic. The guy behind this whole line of thinking is an Oxford philosopher named Nick Bostrom. Now, he didn't come out and say we are in a simulation, but what he did was create this logical argument that suggests there's a very, very high probability that we are. And Bostrom's logic basically boils down to 3 steps. It goes like this. First, just assume that somewhere, someday, some civilizations will become super-duper technologically advanced, okay? Second, assume that those advanced civilizations will want to run simulations of their ancestors, like us, complete with conscious beings. So if both of those things are true, then the conclusion is there are going to be way, way more simulated people than real original people. And if that's the case, just by pure statistics, odds are you're one of the simulated ones. Okay, that is a pretty compelling argument. It's just logic, but it makes some really big assumptions. And this is where we need to switch hats and stop thinking like a philosopher and start thinking like a physicist. Because for a physicist, this whole idea runs into a huge wall, the difference between science and faith. Let's think about it this way. A belief that's based on faith, like a miracle story, tells you what supposedly happened, but it doesn't explain how. The whole point is that you don't need a mechanism. You just believe it happened. Science, though, is completely obsessed with the how. It absolutely demands an explanation, a testable, physical mechanism for how things actually work. And that brings us right back to our simulation. The hypothesis gives us a what. We live in a simulation. But does it give us a plausible, scientific how? From a physicist's perspective, this is where the whole argument starts to fall apart. Actually, there are 2 really big scientific objections that challenge the whole idea. They're kind of the showstoppers for the simulation argument, so let's break them down. From a physics point of view, you immediately hit 2 massive hurdles. First, could a computer program really reproduce the fundamental laws of our universe? And second, you've got this huge technical problem called the information compression problem. Let's tackle that first one. All right, so here's the first huge problem. Bostrom's argument just assumes that some future computer program could perfectly recreate the physics of our universe. And we're not talking about simple physics here. We're talking about Einstein's general relativity and the standard model of particle physics. I mean, these are the 2 pillars of modern physics, and they describe our universe with incredible accuracy. And that is a monumental assumption to just gloss over. As physicist Sabine Hossenfelder neatly put it, it's not easy to outdo Einstein. We can use computers to approximate our laws of physics, sure, but we have absolutely no idea how to perfectly reproduce them from some other underlying computer code. In fact, it's not like they haven't looked. Physicists have actively searched for signs that our reality is running on some kind of grid, that it's pixelated at the smallest scales. A glitch in the matrix, so to speak. And so far, they've found absolutely nothing. Our universe looks perfectly smooth and continuous. Okay, on to the second giant hurdle. the compression problem. For Bostrom's argument about having billions of simulations, especially simulations running inside other simulations, to work, you'd need an insane amount of computing power. So the only logical shortcut would be to compress the information.
This is just like in a video game, where the game only renders the high-quality graphics for the stuff you're actually looking at. The simulation would have to fill in the details only when someone observes something. The problem? The program would have to know what every single conscious being is looking at, and what they're about to look at, and fill in all the details perfectly every single time, without ever creating a contradiction. That's a ridiculously impossible task.
Here's a great way to understand this problem. When our scientists build climate models, they have to take shortcuts and approximate things. But they can check their models against the real world to see if their approximations are any good. But the programmer of our universe, they wouldn't have that. They have no external real world to check their work against. How would they ever know if their compressed, shortcut physics actually works, or if it would just cause the whole system to crash?
So, after all that, where does this leave us? Well, when you start factoring in these enormous, unexplained scientific problems, the simulation hypothesis starts to look less like a scientific theory and a lot more like something else. To sum it all up, the hypothesis is built on these gigantic, unproven assumptions about what computers are even capable of. It doesn't explain how a program could recreate general relativity or how it could solve that insane compression problem. It just assumes, well, it's all possible somehow.
Now, look, this doesn't mean the hypothesis is definitely wrong. We can't prove we're not in a simulation. But it does mean that choosing to believe it requires a leap of faith. It's a belief you have to hold without a testable mechanism, which, as we said, puts it in a category much closer to philosophy or maybe even religion, but not science.
And really, that's the bottom line. The simulation hypothesis is an absolutely fascinating thought experiment. It really pushes us to think about reality in new ways. But when you look at it through the cold, hard lens of physics, it seems to be built on a foundation that needs more faith than it does evidence. So the next time you get that strange feeling that none of this is real, you can ask yourself, am I onto something, or am I just taking a very modern, very technological leap of faith?